Hello and welcome back. Alright, in this video we're going to start stubbing out our classes that we started to define in our whiteboarding exercises. So the first one we're going to start with is that GameEngine class. Now, if we jump over to our whiteboard, that GameEngine class essentially just had a run function. And that run function handles our getting the user input, updating their game logic, and rendering our items to the screen. So let's go ahead and get that stubbed out. Alright, so I'm in Xcode. I'm going to go ahead and right-click Source, New File, call it GameEngine. And you want to make sure that you're adding it into the source directory, especially if you're using Visual Studio right now, and you right-click on the filters to add it under the source. And if you've set it up how we've set up our project here for our cross-platform development, that default location is not going to be in the source directory, but instead it's going to be in the project directory. So make sure you update that. Alright, I'll go ahead and click Finish. Alright, so here's my GameEngine header file. I'm going to go ahead and add I'll go ahead and add the standard header guards. If not, define GameEngine H, define GameEngine H, and if. Okay. So we'll create our GameEngine class. And we know that we have a public section, and we're going to have that run function. Alright. So let's go ahead and go to our CPP file. And we will scope that in. Void GameEngine run. Perfect. Okay, so now we want to jump over to our main CPP file. In our main CPP file, we're going to do include GameEngine. We're going to get rid of this boilerplate code and create an instance of our GameEngine and call run. So if all went well, I can build and succeed. If I run it, nothing should happen. Perfect. Okay, so let's jump over to the whiteboard again. So, we have this piece of it on implemented, or at least stubbed out. Let's go ahead and add this in kind of comment form into our run function, and then we can start filling that out as we see fit. Okay, so we're going to go into our CPP file. First thing, get user input. Second, we're going to update game logic. And third is render the game board. Okay, so let's go ahead and stub at our game board class. That'll be pretty quick. Game board, remember your location. Alright, so let's do pound if not define game board H, define game board H, and if class game board. And if we jump back over to our whiteboard, you can remember that, we had a couple of pieces of functionality that we thought we were going to need, and one of them was render. The board should be able to know how to render itself. Void render. So I know I'm typing through this kind of fast. My intention is for you to kind of watch the video, understand what I'm doing, not necessarily type as fast as I'm typing. If I'm going too fast, be sure to just hit the pause button, because I'm just going to blow out this code and explain the important parts. Okay, so we got our render function. So let's go ahead and actually go to our CPP file and scope that in. Oops. Alright, so we know we're doing a console-based game. And in order to output anything to the console, we are going to need to include the IOStream header file. I'm also going to scope in the cout and the standard line, end line, just so I don't have to, can always scope those with the standard std namespace prefix. Okay, so what do we want to do for rendering our board? This is what I'm thinking. So I'm using the dots to represent a placeholder for the item, for the game piece type. Oops, let's just go and copy paste that. All right, so if we have a setup like this, we'll have we have basically a grid layout right here, right? We have the 3 items on the top row, the middle row, and then 3 items on the bottom row. And that it looks okay, but it's not really what I want. I want to get a better picture, at least a better representation of what the game board looks like. So let's go ahead and add a separator line in here. So in order to do that, I'm just going to come down here, and I'm going to add dashes, 3 dashes and a plus. And I think that looks a lot better. So that way when we render our board, oops, when we render our board, it at least looks a lot more similar to a Tic-Tac-Toe game board. So if I were to build here and run this, you'll see that it doesn't work because we need to go over to our GameEngine CPP file, replace this piece with our board.render. Well, now you might be asking, where's board? That's a good question. So we need to go actually define this. We want a board, a game board instance inside our game engine. So let's go ahead and create a private scope. Okay, game board. Okay, so now we have a board. It's going to get initialized, and our rendering function is defined. If we rebuild, we're going to get some compilers. Let's see, board.render. Yep. So in our header file, what we forgot to do is bring in that game board header file. So the GameEngine class actually knows about it. Okay, so after we do that and rebuild, we can run, and we can see, hey, you know what? That's starting to look like a tic-tac-toe board. So there's one more piece I want to do for this video, and that's to get this rendering fully working. And so in order to do that, we actually need to get these locations, at least in some form that represents something that we can print out X's and O's. So what do we need to do? We need to jump over to our game board. Let's actually jump to the whiteboard real fast. So if we look at our whiteboard and we look at our tic-tac-toe board, we have these 9 positions. And so there's a couple ways we can represent this. Well, there's a lot of ways we can represent this. We can use a list, an array list, a stack, any number of data items, just a normal array, a 2-dimensional array. Some obviously are better suited than others. For example, a stack, not a good data source for this. You could do it, but would be terribly inefficient. A 2-dimensional array would be nice. The problem with the 2-dimensional array is you kind of have to deal with dynamic memory at that point. So I'm actually going to use a single-dimensional array, and then we will do the math to get us into the right location based on the XY coordinates of this guy, this set position function. So the reason I'm doing that is it's easier to work with. The locations are really, we have 0, 1, 2, 3, 4, 5, 6, 7, 8. And so that's pretty simple to work with. So let's jump over to our board. And I'm going to create a char array. And we'll call this locations. And it's going to need 9 elements. All right, and so I want to initialize my board and give it those dots for now. So I'm going to create a game board constructor. All right, so we have 2 things to bring in. We have a game board, We have some sort of setup right here, right? And then our and our header file. Yeah, those are the only 2 functions we have. We know that if we jump back to our whiteboard, we know we wanted this set position, X, Y, and the character. For the piece type. So let's go ahead and define that as well. So I'm going to call this set piece at, and do int x, int y, char c. So basically this is going to set a piece at the given coordinate. Okay, so I'm going to go ahead and copy paste that one over into our header file, our CPP file. And then grab the namespace scope and bring it down. Okay, so our game board initialization. What we need to do is we need to initialize all of our spots with a dot. So in order to do that, I'm going to need two for loops. I'm going to need to iterate over the x positions of 0, 1, 2, and I need to do that 3 times. And we need to do it that way because the function that I exposed is given in x, y coordinates. Now I could directly just manipulate the locations, but I'm going to do it this way. Okay, so for int x, well, x is less than 3. So you might be asking yourself, well, why is he doing it that way? That's a good question. I'm going to do it that way because I want to encapsulate, well, not really encapsulate. I want to keep the functionality of manipulating the board isolated, or as isolated as possible. So if I want to change the type, for example, that I'm passing into to this, like if I want to change this from a char to maybe an enum or to some maybe static class values or something like that, I don't want to have to update the implementation of manipulating the board in multiple places. I just want to do that in one spot. So in here we'll call set piece at x, y. Okay. Yeah, so yes, there is a little bit of a penalty for this, performance penalty, but if we optimize our program, if we profile our program and we realize that, calling set piece at in our initialization, what happens like one time, then okay, we can look at it. But right now, I'm going to keep the readability as high as possible. Okay, so set piece at. What do we need to do? Well, we need to check that our bounds are correct. If x is greater than, is less than 0, or x is greater than 3, then jump out of the function. If y is less than 0 or y is greater than 3, we're done. This should actually be 2. This means if x does not have the value of 0, 1, or 2, then the data that you're giving us into this function is invalid. I don't want to overstep my bounds of my array, so I'm just not going to do anything. We could throw an error or return an error code, throw a C++ exception. There's lots of different ways to handle this. I'm just going to no op. So mine's a silent failure. Okay, so now the next thing we need to do is how do we translate our x and y values into an array position, into our locations array? Well, let's look at our grid setup here. So we know that the top row has the values 0, 1, and 2. We know that the middle row has the locations of 3, 4, and 5. And the bottom one has 5, 6, 7. 6, 7, 8. So we know that x is basically the offset here, and then y gives you the row values. So this starts at 0, this starts at 3, this starts at 6. So we know that the y contributes 3 per row it's in. So if it's on row 1, if it's in this middle row, you know that your value has to at least be 3. So we get an index that looks something like this. X plus y times 3 equals C. And so what's happening is that if x were to equal 1 and y equals 1, well, we need to go over 1, and then we also need to move down 3 more elements, right? And so that's going to put us at position 5 here, right? 0, 1, 2, 3, 4, position 4. That's going to put us position 4 here. So we have 0, 1, 2, 3, and 4. And so x was 1, y was 1, 1 plus 1 times 3 is 1 plus 3, which equals 4. And that's exactly what we want. So that's really all there is to set piece. So the last thing we need to do is we need to figure out how we want to render our location values. Well, we know that a location is just an index value inside that array. So we could try to do something clever and print out this row with the values. You know, maybe let's try to be clever here. All right, so we know we have 3 rows we need to print out, right? So let's call int r equals 0, r less than 3, r plus plus r. Okay, and now we also know that we have 3 columns we need to print out. Okay, so for int c equals 0, well, c is less than 3, plus plus c. Okay, so if our column, basically, if c does not equal 2, then we know we need to print out this bar. Okay. Let's actually do that at the last part. So we know that we need to print a space, the value, and the space. Okay, I know how to do that. I can do cout space locations. We're just going to do that same thing. C plus R times 3, and then a space. So we know we always want that. If our value happens to not equal 2, so that means if we're not in this column, or sorry, if we're in this column, print out a bar. If we're in this column, print out a bar. If we're in this column, don't print out the bar. Okay. That's what that's going to do. So now what we want to do is, you know, if we're on one of these lines, sorry, if we've just got to the end of our row, right, we want to print this out. But we only want to do that if we're not in the last row, because we don't want that at the end. So if r does not equal 2, print this. Alright, let's see if I was too clever for myself. We'll build. Let's run it. I was way too clever. First of all, nothing's printing out correctly. So let's go ahead and see what I did wrong. Okay. So the first problem is I never do an end line, right? At the end of my columns, I always need to end line, regardless. So let's go ahead and rebuild. Okay, things are looking a little bit better now. Now, what are we going to look at here? So now we have two potential issues, right? We could either have the my column piece not working correctly, or my locations setting isn't working correctly. So let's see what's going on. Locations XY plus 3. So I'm thinking this looks pretty good. We got XY up here. We're setting it to the dot. That looks okay. So let's see what locations is here. C plus R times 3. So row is 1. Okay. Or sorry, row starts out as 0. Locations is that. Okay. I mean, that looks kind of good to me. So, So this is the interesting thing, is that I think what we're actually seeing is an issue I ran into before. Let me look at my project here. Let me change this to here. Let's rebuild and rerun. Yeah, so I'm running into this weird issue on my machine. I'll just tell you about this in case you run into it on yours. If I switch my compiler, this bug goes away. And I think it's because I have some preview builds of GCC and Xcode 4 on here. But you'll notice if we go scroll up, nothing was happening. And that was because what we were printing out, locations, was empty, which meant that this wasn't getting called, the set piece at, which meant that this game board constructor wasn't getting called. And that's the bug. The bug is that this constructor is not getting called when it should be getting called. Oops. Sorry about that. We don't need to look at the whiteboard. So that's not getting called when it's supposed to be getting called. But if I change my my compiler, like it was on LLVM GCC 4.2, but when I toggle it to GCC 4.2, it works. If I started on GCC 4.2 and then redo it, it did the same problem. So anyway, all that to say is, if you see that error on your box and you do not have any preview builds of Xcode 4 or of GCC, then log a bug because that should definitely not be happening. But this is what we should have expected to see. We got our printout, and just to prove that this is working, let's go ahead and change this to a star. So you know that it's not my same code, I just cheated. That set piece add is actually getting called. And we are doing a little bit of fancy printing here. I don't know if this really saves us any lines of code well, it does save us line of code, but it does add some confusion. So it's kind of a trade-off. We could have just manually printed these out, but this is a little bit more flexible. We can change our game board size, for example. Like I should actually go ahead and do this. Let's go ahead and jump over to our game board. In our header file, let's go ahead and create two unsigned int constants. We'll call it board width equals 3 unsigned int const board height equals 3. So, in theory, I could change my board size, but my algorithms are all based on 3, which is really bad. So let's go ahead and get rid of all the magic numbers. X, board width, board height. Okay. This is the height because we're dealing rows here. Columns is the width. Okay. And so this is actually going to be board width minus 1, and then board height minus 1. That should be height, not width. Type what I say, not necessarily what I type. Okay, now if I rebuild this, I get 12 errors because I did something stupid. Oh, it's my constant. Forbids initialization member board width. Really? So, okay. So I didn't like that. I did that. Doing those away, that's not going to do it. If I change this to static, then it won't complain anymore. Oh, no, it does. All right. Let's just do this. Constant. Let's add a game board constructor, and then we'll initialize those. All right, so this is the proper way to do it. Sorry. Scope them in. Okay. What? Really? What did I do? Is that not the right syntax? I might be getting confused. I thought for sure that was right. Constants, not that. Well, let's just mark these static. And jump over here. Static. Static. Alright, static may not be used. Oh, obviously we don't do that in the CPP file. Rebuild. All is good. Okay, so now if I actually wanted to change board width, we can see that, hey, we got board width there. And you notice, you know what? I got an error, right? This should be board width minus 1. And this should be board height minus 1. Okay. Which also means that this is wrong as well. So if we want to make this actually correctly generic, what we need to do is basically copy this thing. For every row, we need to do this, right? If it's not that, we need to output dash dash dash. And if it's not the last one, then we add the plus to the end of it. Then we get rid of this. And then we can run it. And we get our boards printing correctly. So let's make sure that we have 3 and 4. Oops. We run again, show the build output, 4 rows, perfect. Okay, so we abstracted this piece out to be correct, got all of our constants out of there, except for those ones. So this is board width, and this one's board width. Okay, now we have all of ours out. Okay, so now the next thing we need to do is make sure this builds, make sure this runs. All right, let's go back to a standard tic-tac-toe game. Run it, good to go. Let's jump over here. Let's do a get status real fast. All right, we want to go ahead and just add everything. Projects. Actually, let's go ahead and update my gitignore file, so I can get rid of this. I don't want to have to keep ignoring that thing. Okay. So now if I do a get status, yeah, everything I want to do is there. So let's just do a git commit dash a. Oops, sorry. Git add source. All right, now if I do a get status, changed but not updated. Let's go ahead and git add or git ignore and git add our projects. Okay. Git status, everything's in there ready to go. Git commit, let's just add the message in line. And let's see here, we added our stub game engine and game board classes. Okay, let's go ahead and add that up. Git push, pushing. All right, let's jump over to Visual Studio. Let's do an ls. All right, we have a tic-tac-toe project, good. Let's do a git pull. So pull down all of our files. Okay, great. Let's go ahead and open up our Visual Studio project. Tic-tac-toe.vcxproj. Okay, so what we want to do is we want to add all of our existing files over in Visual Studio, make sure everything builds over here and is working, and do some proper cross-platform testing. So I just added all the CPP files and the header files into the same filter, and then just drag the header files up there. That's just a code organizational technique that I like to do. Okay, so Control-Shift-B, get everything building. Build succeeded. Let's do a debug. Start without debugging, and voila, we have all of our items printed, and everything is looking good. So I'm pretty happy with all of this. Let's go ahead and save all. Let's do a git status. I'm actually going to go ahead and add all of these. Let's see if I can do this. Notepad.gitignore. Let's go ahead and get rid of all these files. We don't want any of that. Oh, those aren't tabs. These are all user files, and I just don't want to get bogged down every time we're doing these videos to get rid of those. Okay, so now if we do get status again, those things are looking pretty good. I want all of those in there. We can go ahead and add git ignore and projects. Get status, perfect. Git commit, pass in our message, updated Visual Studio project file with new code files. And then do git push. And voila! We now have all of our code into GitHub. Let's actually just go ahead and show you GitHub. You can see that all of my code has now been uploaded into GitHub and all things are happy. Yay! If we look at our commit history, we can say, yep, here they are. Those are the two things we just did. So, in this video, we stubbed through all of our GameEngine and GameBoard classes and added our Visual Studio project file updates so that we can be compiling and working on both platforms. In the next video, we'll go ahead and take a look at fleshing out some more of those details. All right, thanks.